Hello, ladies and gentlemen, and welcome to the first of the lessons on sequences and series. And this lesson, as many of the previous lessons, has been brought to you directly from my dining room table. So thank you for tuning in. So let's take a look. You all have the note page. So a sequence, let's see if this is, oh, never mind, let's get rid of that. So sequence is an ordered list of numbers. Let's see about writing here. So I'm still playing with this tablet. So a sequence is an ordered list of numbers. Each number of a sequence is called a term or an element. So a finite sequence contains a finite number of terms. You can count them. In some math classes, they may call it a countable set. All right, you can count the number of elements in the set. Okay, an infinite sequence contains an unlimited number of items or terms or elements. And we'll be doing problems with both finite and infinite sequences. Okay, so let's take a look at some sequences here. Here's an example of one, and in order to look at this, I don't know what that was, in order to determine how this sequence is changing, you've got to look at this. And how do you get from 1 to 2 to 3 to 4? And the way you do that is you take the previous term and you add 1. That's how you get to the next term. Now let's take a look at this next sequence. Numbers are going down and down and down and down. And how do I get my next term? I subtract 3. Okay, pen, let's go. So we subtract 3 to get to the next term. All right. An arithmetic sequence is a sequence in which each term is obtained from the previous term by adding or subtracting, depending on whether it's positive or negative, something we refer to as a common difference. And when we're looking at a formula, D is the difference. D could be positive, D could be negative. Okay. The first term of the sequence is denoted A sub 1. See that little 1 that's down below here, like this, right? Okay, that's we say A sub 1. This one is A sub 2, and so on up to the whatever the term is, the nth term. We don't know what that is all the time. That's A sub n. N is the number of terms: 7th term, 20th term, 87th term. Okay. So let's take a look at this example. Find the next 4 terms in this arithmetic sequence. So first you have to figure out what D is. So if you look at this, D is 3. So the next terms would be 15, 18, 21, and 24. Okay. 12 plus 3 is 15, plus 3 is 18, so on. So let's take a look at this one. Find the common difference for each of these sequences. So if we look at this, how do you get from 7 to 11? So the difference is adding 4. If we look at this last one, the numbers are going down, so our D will be negative, and the D here is minus 3. Okay, let's look at the next page. If we're trying to find a particular term in the sequence, for instance, we're trying to find the 5th term, the 17th term, whatever that is. So the nth term, the one we're trying to find, is a sub n. The way you find that is you take the first term in the sequence plus, what term are we looking for? We're looking for the 15th term. N is 15. 15 minus 1 times the common difference. Okay? So let's take a look at the formula in use. So we want to find the 68th term in this sequence. So we're looking for A sub 68, 68th term, okay? And that is the first term, which is 16, plus, oh wait, what's the common difference here? Let's take a look at this. We need D for our formula, so let's take a look and see what our common difference is. D is -9. 16 minus 9 is 7. 7 minus 9 is -2. Okay, let's go back to the formula. 16 plus, we want the 68th term, and we're going to subtract 1. And we're going to multiply that by -9. Alright, so if we continue this down, our 68th term is equal to our first term of 16 plus 68 minus 1 is 67 times our common difference of -9. At this point you can take your calculator out. It becomes pretty much a calculator problem at this step. So our 68th term again is equal to our first term of 16 plus 67 times 9 is -603. So 16 minus 603 is -587. And that's our 68th term. Now, if you so wanted to, you could sit here with the calculator and subtract 9 68 times, starting at 16. So if you want to do that, you could do that. You could say 16 minus 9, hit enter, minus 9, hit enter, and you could do that for 68 times. So if you wanted to prove that it really works, you'd be my guest. You can manually do that. I personally, I'm not going to do that. If you don't trust that the formula is right, have at it. You can feel free to go and do that. All right, let's do another one. We want to find the first term in this sequence. All right, the 31st term is 197. So if you go back and look at the formula says the nth term. Well, the 31st term, you're given. You have to find a sub 1, or the first term. Okay? So, let's take a look at this. So, the formula says the nth term, so that's going to be 197 equals the first term plus 31 minus 1 times 10. You have the common difference here of 10. The 31st term, that's n. There you go. 31 minus 1. Okay? So 197 equals our first term plus 30 times 10. So 197 is equal to our first term plus 300. It's an algebra problem. Subtract 300 from both sides. So -103 is a sub 1, our first term. These, by the way, will cancel out. So our first term of this sequence is negative 103. The 31st term is 97. The common difference is 10. Okay, so sometimes, oh, I think I missed something here. Did I forget to copy something onto this page? I think I may have. If you look at the bottom of your sheet, it says sometimes we may know two terms, and maybe a first term and the last term, and we need to find the terms in between them. So the example that's on your sheet is negative 11, and it says form an arithmetic sequence that has 5 arithmetic means between negative 11 and 19. Okay, so if we look at this, the terms between any two non-consecutive terms in an arithmetic sequence are called arithmetic means. So let's take a look. The best way to do this is draw this out. So we want 5 terms. 3, 4, 5. So between negative 11 and 19, we want to put 5 terms in there. We don't know D, right? So if we look at this, D, we don't know. We can use our formula. The nth term is 19. And so that's equal to our first term of negative 11. And how many terms do we have here? 1, 2, 3, 4, 5, 6, 7. Oh, there's a plus sign here, sorry. Plus 7. Oh, I have to get the eraser. Let me just erase this. I'm going to start over with this formula thing. I'm going to change color. Maybe color will help. Alright, so the last term of 19 is equal to the first term of negative 11 plus 7 minus 1 times, we don't know D, so we're just going to put a D here. Instead of an X, we'll use the D, because we're trying to find the common difference. Okay? So 19 equals negative 11 plus 7 minus 1 is 6, 6D. Okay? Let's solve this for D. So we're going to add 11 to both sides. $30 equals 6D. D equals 5. Okay, so now we know we have to add 5 to each of these terms. Negative 11 plus 5 is negative 6. Plus 5 is negative 1. Plus 5 is 4. Plus 5 is 9. Plus 5 is 14. Plus 5 is 19. So that's how we can find any of those terms in our sequence. So that wraps up the screencast. Let me just make sure I want to make sure I didn't miss anything. Yep, that wraps up the screencast on the first lesson on arithmetic sequences. So thank you for tuning in to this edition of Math 12R Flipped Classroom Screencasts. I'll see everyone in class. There is a quiz attached to this, so make sure after you watch the screencast you do take the quiz and submit the quiz on time. So thank you for tuning in.